In the next set of examples, we're going to continue working with our basic derivative rules. We're going to add this general power formula here, which is basically the chain rule in the form that we use. So, quick reminder, if we have a function to a power, where n here is a real number, the n comes down front, leave the function the same, subtract 1, multiplied by the derivative of the function. That's a specific example of the chain rule, which we have written here, where we have a composite function, where we take the derivative of the outside function first, multiplied by the derivative of the inside function. In this case, the outside function is the exponent, the inside function is f of x. So in this case, p prime of x, we take the derivative of the 4, the exponent first, so the 4 comes down, 1 minus 3x squared stays the same, and 4 becomes a 3, times the derivative of that part that was in brackets, so the derivative of 1 minus 3x squared, which is negative 6x. And we can simplify that, negative 24x, multiply these, 1 minus 3x squared to the power of 3. And so that's our derivative. We're going to add two more rules now, or hopefully just remind you of two more rules. We have the quotient rule. So anytime we have a quotient, the derivative is the derivative of the top times the bottom minus the top times the derivative of the bottom all over the bottom squared. So that's the rule we'll use here. Since we have a quotient, the derivative is going to be derivative of the top, keep the bottom. So I'm going to keep the bottom here first, minus keep the top, so that's 3x squared plus x. And we're going to need the derivative of the bottom all over the denominator or bottom squared. So we need to fill the derivatives in these two. So this is the derivative of the top here, which is going to be 6x plus 1. 3 times 2 is 6. X to the power of 1. Derivative of x is 1. And this one needs to be the derivative of the bottom. That's this part here. So 1 minus 4x, the derivative is minus 4. And there's the derivative. We can simplify, but at the moment we're just going to focus on taking the derivative. So I'm going to leave it like that. This is a quotient, but it also has a chain. So a little bigger. First thing we're going to do is rewrite the square root as power of a half. There's very few times that we're going to want to leave the square root sign. It's easier to use as the exponent. So we'll start by rewriting this as 5 over 2 over 7x squared. Now we can use the quotient rule and the chain rule and see if we can get the result. So quotient rule, derivative of the top. So we need the derivative of this piece. And that, we need to use this rule as well. So 5 over 2 comes down. Inside stays the same. 5 over 2 minus 1 is 3 over 2. Times the derivative of the inside. So that's going to be 6x minus 1. So that's the derivative of the top. Now we need to keep the bottom. So that's times 7x squared. Minus, keep the top, so we keep 3x squared minus x to the 5 over 2 times the derivative of the bottom. So the derivative of 7x squared is 14x. And that's all over the denominator squared. So 7x squared all squared. And that's the derivative. Lots of things we can do. Simplify, multiply here. Maybe just move this out front. You could factor out the common x's if you wanted. But at the moment we'll just focus on the derivative. You'll have to check with your teacher how much simplification they really want you to make here. Next example, we're going to use this last rule written here, and this will be the last example for this video. And this is the product rule. And the product rule says we take the derivative of the first term, keep the second the same, plus keep the first term, and multiply by the derivative of the second term. So we're going to take the derivative of the first term, and we'll fill that in a second, and keep the second term the same, so that one's not going to change, plus then we're going to keep the first term, and term is not really a good word to use there, keep the first factor, first function, and the derivative of the second. So the derivative of the first here, minus 1 minus 4x, that's the derivative of that. We kept the second, then we keep the first, and derivative of the second is 4x cubed minus 1. And that's the whole derivative. Again, simplifying, you can expand, lots of little things you could do. Get clarification from your teacher how much you need to do, because this here is the derivative. It really depends on what you're going to use it for, how much simplification you'll really need to do.